Yeah. What we dis so what we were discussed yesterday, we discussed about the Kubernetes, right, guys? Kubernetes easy. Kubernetes solve all the problems. So Kubernetes, it's a orchestration engine. Okay, it is an open source software. Okay, it is used to manage containers and our applications. Okay, it will okay, take care of the container deployment, scaling, descaling, container load balancing. Okay, it is not a replacement for the Docker. It's a replacement for the Docker SAM. Okay, it is developed by the Google and donated to CNCF in 2014. CNCF means Cloud Native Computing Foundation, software developed by using the Go language. So K8 starting version is was 1.0 released in the market in the year of 2015. 2015, right, guys? You understand about the Docker, Salmon Docker, the futures, so architecture. Yeah, you guys are understood about the architecture, right? So Kubernetes architecture. So what is the Kubernetes architecture? So the control plane. So control plane is nothing but a master node. These two are the worker nodes. In the master node, so what are the services are available? API server, scheduler, controller manager, and etcd. So these are the services in the master node. So these services will handle the worker nodes automatically. Will handle the worker nodes automatically. How we can connect these control plane? So you are connecting these control plane to via UI means so you can use the RKE Ranger Kubernetes engine or OpenLens. You can use these tools and you can connect. Or CLA, you can use the CLA command same like as a kubectl. So kubectl. So what are the worker node components? So in the worker node, it's called it as a so the container, right? In the Kubernetes architecture, pod will be so in the within the pod there is a containers. Pod is a just like a logical unit. So within the pod we can run the containers. We can run the containers. This is the Docker runtime. Docker runtime is nothing but a Docker service is starting. Kubelet. So Kubelet will validate if the pod is running or not, if the container is running or not, node is running or not. So kubeproxy is nothing but a networking. So we need to provide the networking for the pods, right? So kubeproxy is for that purpose. Guys, now you understood the architecture of the Kubernetes. Is it easy or difficult, guys? So Kubernetes is a orchestration tool. It manages the containers. It manages the containers. Guys, understood? Yeah.
Yes, sir.
So what is a scheduler? So what are those? A scheduler and API server, control manager, etcd. What is a scheduler? So what is a scheduler? It will schedule the pods for execution which are unscheduled based on etcd. So based on etcd. So it will schedule the pods for execution which are unscheduled based on the etcd. So what scheduler is doing? Scheduling the pods. Scheduling the pods. In the scheduler itself has a meaning schedules. So it will schedule the pods for the execution which are unscheduled based on the etcd. Etcd is the repository. So we are storing the data in the etcd. Scheduler will schedule the pods on the nodes with the help of kubelet. Guys, understood? So kubelet is manages. So kubelet is manages what kubelet is doing. So kubelet is so it will so the who will manage the worker node? The kubelet will manage the worker node. So this scheduler that kubelet is check that kubelet is checking. So from the scheduler it will ask to the kubelet. So I want to execute the pod. So I want to execute the pods. How we can execute if the unscheduled pods, right? So scheduler will schedule the pods on the nodes with the help of kubelet. Kubelet is a worker node component. What is this, guys? Kubelet is a worker node component. So kubelet is a worker node component. Scheduler will talk to kubelet. Scheduler will talk to kubelet to each to check the resources to to our own application. So it will talk to the kubelet. Scheduler will talk to the kubelet and check the resources. Guys, understood? So this is nothing but a scheduler. What scheduler is doing? Guys, what scheduler is doing? Scheduler is scheduling the parts, whatever the unscheduled part is there with the help of kubelet. With the help of kubelet, it will schedule the parts. Now you understood about the scheduler, right? Guys, understood, right? So what is a kubelet? Kubelet will act as a node agent. What is this, guys? Kubelet will act as a node agent. What this is, guys? A worker node agent. So node agent, it will communicate from master to worker. Who is the agent? Kubelet is the agent. Kubelet is the agent. Kubelet will ensure that the containers are running healthy in the pod. In the pod, it will check. In the pod, it will check. Kubelet, it will check in the pod the containers are healthy or not. So Kubelet will ensure that the containers are running healthy in the pod. Kubelet will interact with the runtime to create a container in the pod. Kubelet will interact with the runtime to create a container in the pod. Note here we will use the Docker runtime to create our containers. So Kubelet will interact with the Docker runtime, interact with the runtime to create the container pods. Guys, understood? Who will schedule unscheduled pods? We will schedule the pods. So the scheduler. Now we understood about the kubelet and the scheduler. So now you understood about the scheduler and the kubelet. So kubelet. Now you understood, right, guys? Kubelet is the agent node or worker node agent. It will verify it will verify the all the pods are up and running healthy or not, and it will create the pods by using the Docker runtime, right? It will check the what are the scheduler parts is providing in the master node. Who will checking? The kubelet is checking. So who will scheduling? Scheduler will say scheduling. Guys, understood how to communicate with K8s? To communicate with K8s cluster, to communicate with the Kubernetes cluster, we have two options. So to communicate with the Kubernetes cluster, we have two options. One is UI interface, the other one is kubectl. So what is this, guys? So one way is UI, one way is the UI, the other way is the kubectl. The other way is the kubectl. Open lens. Yeah, guys. So this is the open lens, guys. What this is? This is a open lens, guys. Yeah, you see here. So this is the your cluster. So these are the parts. These are the parts, guys. These are the parts. How we can manage our Kubernetes cluster? One is OpenLens, another one is RKE. RKE, RKE cluster. Yeah. So this is the cluster management, right? So if you can click it, yeah. So this is the Ranger web UI, right, guys? You understood? Yeah. So this is the clusters, guys. This is the clusters. You can once you can click it, it automatically shows the parts and services. I think this is a yeah. So boot volume this is. Yeah, guys. So this is the Rancher Kubernetes engine. So Rancher Kubernetes engine. So we can check it. This is guys. So this is the so this is the container. Container is running. What this is guys? This is a Rancher. So you can connect the cluster two ways. You can connect the cluster two ways. The two ways. One is UI, so UI, and the other one is kubectl. The same way AWS console, right? For example, this is AWS console. So how many ways you are connecting AWS console, guys? Guys, how many ways you are connecting the AWS? Guys, speak out. How many ways you are connecting AWS? So for example, this is your AWS cloud. AWS cloud. So how many ways you are connecting this AWS, guys? One is AWS console. What is that, guys? Guys are able to
Okay.
hear my voice?
Yes, sir. Yes, sir.
So AWS console.
Confirm.
So one is AWS console. So the other one is AWS CLI. What is that, guys? The other one is AWS
AWS CLI.
CLI. AWS CLI. So you are connecting with your AWS cloud either two ways, AWS CLI and AWS console, right, guys? AWS console and AWS CLI. The same way your master node. What is that, guys? Your a master node. Master node is nothing but a Kubernetes cluster, K8s cluster. So how you are connecting with how many ways you are connecting with your Kubernetes cluster? You can connect Kubernetes cluster with two ways. What are those, guys? What are those? Guys, speak out, guys. So one is UI, right? UI. So in UI, so one is UI and the other one is CLI. So one is UI, user interface, and CLI, command line interface. So what are those, guys? So we already discussed open lens. Open lens is one, and RKE also we can use the GUI. So what is here? Here we can use the CLI, only one command, that is kubectl. Kubectl command, we can connect this server. So we can connect this server. Guys understood? Guys understood or not? Hello?
Understood. Yes, sir.
Yeah, guys. So to communicate with the Kubernetes cluster, we have two options. One is UI, user interface. The second one is kubectl, the CLI. Master nodes manages the worker nodes in the cluster node. So what? Master node manages the worker nodes in the cluster. It will assign task to the worker node for execution. It will assign task to the worker nodes for execution. Worker nodes will run the tasks which are assigned by the master node. What is that, guys? Master node manages the worker nodes in the cluster. So master node manages the worker node in the cluster. Worker node in the cluster. Worker nodes will run the task which are managed by the master nodes. Which are managed by the master node. So what is API server? What is this? What is API server? API server in Kubernetes cluster, we have several services and objects. So in Kubernetes cluster, we have several services and objects. So what are the services object? The services are pods, replication controller, replication set, daemon set, deployment, volumes, services. These all are the Kubernetes cluster services or a objects. Pods, replication controller, replication set, daemon set, deployment, volumes, services. Volumes, services. All the above K8s services implemented by using Go language. These to use Kubernetes service we want, so we no need to learn the Go language to use the Kubernetes services. K8s provider provided API services. K8 is provided API services. So when we execute a command, API server will interact with Kubernetes software and it will perform on the required operations. Guys, understood? So create cluster, we have several services objects. So what are the objects? Pods, replication controller, replication set. I will tell you guys, replication set. It is most important in the replication controller, replication sets, pods, daemon sets, deployments, volumes, services. Guys, tell me, what are the services and objects? What are the services, guys? So Kubernetes cluster services and objects. What are the services or objects? Guys, speak out. Very good.
Replication controller.
Replication controller,
Mm-hmm.
replication set, daemon set, deployment, volumes, and service.
Services.
All the above Kubernetes services implemented using Go language. To use Kubernetes services, we need to learn Go language. No need to learn Go language. To use Kubernetes services, K8 provided API server. When we can execute the command, API server will interact with the Kubernetes software. So command API server. If I execute any command in the kubectl. So for example, kubectl apply. So we can kubectl apply something like pod deployment .aml file. For example, this is the deployment file. So when I run, so kubectl apply deployment.aml, so deployment.aml, so it will connect to the master node, and master node whatever the deployment file, right? That deployment file will taken care by the API server. So API server will check it and copy it under the etcd repository. Then it will communicate with the kubelet. Then it will create the pods under the worker node. Pods under the worker node. Guys, understood? So when we execute the command in the API server will interact with the Kubernetes software and it will perform required operation. So whatever the command, right? kubectl apply or deployment.aml. So who will execute this command? API server will interact with this command and Kubernetes software and it will perform the required operation. API server will act as a communication. API server will act as a communication channel between developers, DevOps engineers, and Kubernetes component. So Kubernetes components. HCD. What is HCD? It is a key value pair data store in Kubernetes. What is that? Data store. It's a repository. So whatever the deployment file, right? The deployment file will be deployment.aml will be stored under the HCD. It's a key value pair data store in Kubernetes. It acts as a database for the Kubernetes. Guys, understood? It acts as a database for the Kubernetes. How many pods, how many nodes, how many containers, etc. So it will manages. So when we ask the Kubernetes to run our application, then API server will receive that request and it will store it in the HCD. It will store it in the HCD. So guys, kube proxy. So what is a kube proxy? Kube proxy act as a network proxy. What is that? Kube proxy. Kube proxy act as a network proxy. So proxy act as a network proxy. Proxy will maintain network rules on the pods. The network rules allow network communication to your pods from inside outside your cluster. So we can open the ports, right? 80 ports. So within the container and so on the pod node. So what is a control manager? So what is a control manager? Control manager runs controls in our backgrounds. It is responsible to run the tasks in the Kubernetes cluster. It performs the cluster level operations. It performs cluster level operations. So we have several controls in Kubernetes: node controller, replication controller, endpoint controller, deployment controller. So what are we have several controllers in the Kubernetes: node controller, replication controller, endpoint controller, deployment controllers. Okay. So what is a pod? So here Kubernetes. So within the pods containers are there, right? So what is a pod? Pod is a smallest execution unit in the Kubernetes. What is that, guys? A pod is a smallest execution unit in the Kubernetes. A pod encapsulate one or more applications. So container will be grouped as one pod in order to increase the intelligence of resource sharing. Container will be grouped as a one pod containers. The containers will be grouped as a one pod in order to create a intelligence of resources sharing. Pod can run single container as well as the multiple containers. So in the pod, so we can run a single container. So we can run as a single container or a multiple containers because of, so we need to communicate, we need to share the network, we need to share the volumes, we need to share the everything for that pod. So that's the reason pod is using. A pod is the smallest execution unit in Kubernetes. Pod encapsulate one or more applications. Container will be grouped as a pod in order to increase the intelligence of our resource sharing. Pod can run single container as well as a multiple containers. Guys, understood? Yeah. So K8S diagram, Kubernetes architecture. So guys, understood, right, guys? So this is the master node and this is the worker node. So what it is, kubectl is the command mode in order to perform the operations on the master node. So what is that, guys? Kubectl is the command mode in order to operate, in order to perform the operations on the master node. So this is the master node. If you want to perform any actions, or you can use the kubectl. So run the command on the kubectl. Run the command on the kubectl. This is the worker node. For example, this is the so nginx webpod web app pod.ml manifest file. So what it is there, API version kind equal to pod. So kind, right? So I will tell you everything. Pod metadata name nginx spec containers. So nginx container image and ports 8080. On ports 8080. So we can share it, guys. Why this came into the picture, guys? Cut. So as of now, I'm pasting here, but I don't know where we need to use this. Okay. Yeah. So this is the worker node. This is the master node. kubectl is the command mode in order to perform the operations on the master node. In order to perform operations on the master node. So execute a command by kubectl that will talk to the API server. So once we execute the command, it will talk to the API server. API server will act as a mediator between kubectl and Kubernetes software. This is the API server will act as a mediator between kubelet and the Kubernetes software. Guys, now you understood? Execute a command. Execute a command by the kubectl, which will talk to API server, and API server will act as a mediator between kubectl and Kubernetes software. So whenever a request comes from the kubectl, that will be taken care by the API server, will talk to underlying Kubernetes software. So whenever a request comes from the API server, API server stores the information in the HCD server first. So whenever you execute the command, right, it will get the API server. So the pod.aml file, right, the manifest file. So it will store under the HCD. So HCD is the data store in the Kubernetes, and it will act as a database to store the details on the Kubernetes server. Scheduler is going to check that what are the pending tasks are available. Then scheduler is going to assign the task to the controller manager. The scheduler is assigned to the controller manager. Assigned to the controller manager. Controller manager is going to schedule them before going to schedule. So scheduler will talk to the kubelet. So kubelet is a worker node agent. It is going to check the health of the node. It is going to check the health of the node. Kubelet will check the resources available in the node. Kubelet will make sure pods are running successfully and containers are running successfully. Kubelet will create a container on worker nodes using the pods with the help of the Docker runtime. Docker runtime is where we are using to create the containers. Container is nothing but a runtime of our applications. So this is the Kubernetes diagram. Guys, understood? Guys, understood about a little bit you understood about, right, guys? Kubernetes cluster setup. There are multiple ways to set up Kubernetes cluster, self-managed Kubernetes cluster and provider managed Kubernetes clusters. What are those? There are multiple ways to set up Kubernetes cluster, self-managed Kubernetes cluster and provider managed Kubernetes cluster. So provider managed Kubernetes cluster. What are the provider managed Kubernetes cluster, guys? Tell me. So AWS provides what is the Kubernetes cluster, guys? The service name. Guys, so what AWS provides the services? So what is ECS means? Elastic Container Service.
Service.
So what Kubernetes service? EKS. Elastic Kubernetes Service. So this is AWS. So Azure AKS. Azure K8S Service. So Google GKE. Google Kubernetes Engine. Google Kubernetes Engine. OKE. OKE means, guys, Oracle Kubernetes Engine. Guys, these are the provider managed Kubernetes service. Guys, speak out. So what are the provider managed Kubernetes services, guys? So what are the provider managed Kubernetes service? EKS by AWS, AKS by Azure, GKE by Google, OKE by Oracle, IKE by IBM, Alibaba, something else. Guys, now you understood? So what are the provider managed Kubernetes cluster? These are the providers. What are the providers, guys? Amazon, Azure, AWS, Azure, Google Cloud, Oracle Cloud. So these are the provider managed Kubernetes clusters, guys. Guys, understood?
Yes, sir.
Yeah. Self-managed means we need to create our own cluster setup. So we need to create our own cluster setup is nothing but a self-managed. So provider managed means so the providers. Self-managed cluster means we have to set up the clusters of Kubernetes to run our application. So to run our application, a lot of commands need to install. So to create a self-managed cluster, we have two options. So one is Minikube, the other one is KubeADM. So Minikube is nothing but a single node Kubernetes cluster. What is that, guys? Single node Kubernetes cluster. So this is right. So Minikube is nothing but a single node Kubernetes cluster. So within the single node, master and worker both are in the one node. So both are in the one node. For example, this is EC2 instance. In one EC2 instance, so this is a mini cube. Mini cube, both worker node, master and worker nodes, worker are both are in the one node. This is nothing but a node. Guys, understood? So this is using in the development purpose. They are using in the dev environment. They are using in the QA environment. Guys, understood?
Yes.
Self-managed Kubernetes, self-managed cluster means we have to set up the cluster of Kubernetes to run our applications. So to create a self-managed clusters, we have two options. One is Minikube, other one is KubeADM. So Minikube is nothing but a single node Kubernetes cluster. KubeADM is nothing but a multi-node Kubernetes cluster. So multi-node Kubernetes cluster is nothing but a, so this is a multi-node Kubernetes cluster, right? Single node Kubernetes cluster is nothing but a, in one node we can we can use as a master node. We can work as a master node as a non-worker node. So KubeADM, KubeADM is a tool designed to bootstrap our full-scale Kubernetes cluster. It takes care of the all heavy lifting related cluster provisioning and automates the process completely. KubeADM is a tool designed to bootstrap the full-scale Kubernetes cluster. Full-scale Kubernetes cluster. It take care of the all the heavy lifting related to cluster provisioning and automates the process completely. So set up a Kubernetes cluster. Kubernetes cluster setup. How we can set up the Kubernetes cluster? So Kubernetes cluster, a cluster we can set up in multiple ways. Self-managed and a managed Kubernetes cluster. Self-managed is nothing but a KubeADM multi-node cluster and a Minikube single node cluster. So self-managed, we can manage the Kubernetes cluster, AWS EKS, Azure AKS, GCP GKE, IBM IKE, Oracle OKE. Guys, these are the managed Kubernetes cluster. So Kubernetes cluster setup, provider managed cluster means we will use we will use the Kubernetes cluster which is configured by the someone. What is nothing but provider managed cluster means, so we will use Kubernetes cluster which is configured by someone. So if you took the any services, right, it automatically predefined services. So what is that? 8KS Elastic Kubernetes Service, 8KS Azure Kubernetes Service, GKE Kubernetes in Google Kubernetes Engine, IKE IBM Kubernetes Engine, OKE Oracle Kubernetes Engine. Guys, understood? These are the provider managed cluster means. So we will use the Kubernetes cluster which is configured by the these providers, which are configured by the these providers. No need to no need to create a cluster setup. EKS by AWS. So what is that, guys? Elastic Kubernetes Service. So what is that, guys? Elastic Kubernetes Service. So what is the service, guys? EKS. Elastic Kubernetes Service. So what this is, guys? So this is the Elastic Kubernetes Service, fully managed Kubernetes control plane. So you can, so it will automatically manage it, guys. Amazon EKS is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes control plane or own control plane. So it will, who will manage this, guys? AWS manages. So how it works? So Amazon EKS exposes a Kubernetes API endpoint. Your existing Kubernetes tool can connect directly to the EKS managed control plane. Worker nodes run as a EC2 instance in our account. In our account. Guys, understood? So clusters, add clusters, create a cluster or register cluster. For example, create a cluster. You can create the cluster name, the cluster names and worker nodes API, everything you can connect, guys. So what you can do is the task, guys. What is it, guys? EKS. So what is EKS, guys? Elastic
Kubernetes service.
service. Yeah, guys. How to install and launch EKS on AWS. Check it in the web, guys. Check it in the web, guys. You will understand about the EKS. Okay, check it in the web. If you can go through it, any YouTube videos or any wikis, you can check it how we can configure the EKS. Okay, guys, this is our task, guys. Just check, just to see, you will understand more about the EKS. Okay. Yeah, Elastic Kubernetes a service. So Kubernetes cluster setup, how we can set up Kubernetes cluster setup, create one security group with the protocol as all traffic port range 0 to 65535. Create 3 Ubuntu servers using above created security group. So one is master node, T2 medium instance, 2 is worker nodes, T2 micro instances, guys. So what you can do, guys, you can do, so you can use anyone, guys. You can use the Ubuntu servers. You can create the Ubuntu servers using the above created security group. So security group already default security group. In that default security group, you guys can um, add the all port range, guys, master node, or you can create a one security group, guys. So master node and worker nodes, master node and worker nodes. Kubernetes minikube meaning, guys. So what is Kubernetes minikube meaning? So minikube is a one node Kubernetes cluster where the master process and worker process both run on one node. What is that, guys? Minikube, guys, speak out. What is minikube? Minikube is a, guys, read it. Guys, what is minikube? Funny?
Minikube is the
Auku funny
one node in
unnada?
the
Auku
Kubernetes.
funny.
Sir,
Yeah, what is Kubernetes? Minikube?
Minikube is one more Kubernetes cluster where master process, work process both run on one node. According to the official recommendation of Minikube, Minikube is local Kubernetes, focusing on making it easy learn and develop for Kubernetes. If for people to use Minikube is Docker
Prerequisites to use.
Minikube is a Docker container or virtual machine environment. Minikube provides you a way to easily deploy application on Kubernetes for learning and developing purpose, even if you don't have enjoy resources like memory, CPU, etc.
You don't have enough resources. You don't have enough resources like memory, CPU, etc. So minikube is a one node Kubernetes cluster where master process and worker process both are run in one node. According to the official documentation of the minikube is a local Kubernetes. Minikube is a local Kubernetes focusing on making it local. So it will not use it under the enterprise. Enterprise means in the production. It will use it in the only development environment or a QA environment. Kubernetes focusing on the making it easy to learn and develop for the Kubernetes. So a prerequisite to use minikube is a Docker container or a virtual machine. So you can use as a virtual machine only, as a virtual machine is a minikube. Minikube provides you to use Minikube provides you a way to easily deploy application on Kubernetes for learning and developing purpose, even if you don't have enough resources like memory, CPU, etc. So these are the pages, guys. So these are the how to set up the Minikube and how to. So this is the follow the pages. Yeah. So set up the Minikube. You can use this URL. Okay, so Minikube, what is a Minikube? Minikubes quickly set up a local Kubernetes cluster on Mac OS, Linux, Windows. We proudly focus on helping the application developers and new Kubernetes users. So new Kubernetes users. So something like this is a Minikube start. So Minikube start highlights support the latest Kubernetes release, cross-platform Linux, Mac, OS, Windows, deploy as a VM, as a container or a bare metal. So multiple containers runtimes, CRI, Containerd, Docker, Direct API endpoint for blazing fast image loading and build advanced features such as a load balancer, file system mountings, feature gates and network policy, add-ons for easily installed Kubernetes applications, support a common CI environment. So this is the highlights of the Minikube. Kubernetes cluster architecture. What this is, guys? So this is the Kubernetes cluster architecture. So this is the AWS cloud. This is the VPC subnet. So this is the your created VPC. So what is this? So this is the EC2 instance, EC2 instance, EC2 instance. You can take the three EC2 instances. You can take the three EC2 instance. So one is master node. This is for T2 medium instance. Worker node purpose. You can take T2 micro instances. So guys, you can create with master node, T2 medium, and worker node for micro instance. Once you create it, right, you can stop it. So we'll show you tomorrow how to install the Kubernetes cluster. So Kubernetes cluster architecture. So this is the EC2 instances. These all are the EC2 instance. So T3 and T2 micro. These all are the T2 micro, and this is the Ubuntu OS is installed. Kubernetes master, Kubernetes worker node, and Kubernetes worker node. These are the two worker nodes. This is the one master node. In the one master node, Kube control manager, Kube scheduler, Kube API server, scheduler, control manager, um, kubelet and etcd, kubelet and etcd. So how you can interact with this worker nodes? How you can interact with this worker node through the API, right? So in the worker nodes there is a kube proxy and the container and the pod kubelet will be there, guys. So this is the Kubernetes cluster architecture. Kubernetes cluster architecture, guys, understood? Yeah, self-managed setup. Kubernetes self-managed setup. Take three Ubuntu VMs. One is master node, the two worker nodes. Install Docker Kubernetes in both master and worker nodes. Install kubeadm kubectl in only master node. What is that, guys? kubeadm and kubectl in the master node, but install Docker and Kubernetes both master and worker nodes. So this is the setup, guys. This is the setup we need to follow. So master and worker node setup. So master node and worker node commands to execute. So these are the commands we need to execute in the Docker and master node setup. Master slave common commands these are. So installing Kubernetes. So how you can install the Kubernetes master node commands, worker node commands. So is it recommended to run the command in the master node? So we can access the master node from the remote mission using the kubectl command. For example, you can create another mission and you need to connect from the master node and worker node, because of if you done anything on the master node, definitely it will be crashes, right? That's the reason we need to take another server and run the kubectl commands over the master node. Launch a new EC2 instance VM for running the kubectl commands. So yeah, we need to run the kubectl commands, right? Kubernetes core components. What are the Kubernetes core components? Kubernetes resources and objects workloads. So what are the core components? Container, pod, namespaces, service, and deployments. What are the Kubernetes resources? Core components. What are the core components? Kubernetes resources, objects, and workloads. These are the resources, objects, and workloads. So container, pod, namespace, service, deployment. Namespace, service, deployment. Yeah, guys. I will give you the documentation how to install the Kubernetes. So this is our drive, guys. In that drive, I will share you my computer. My computer. So what it, guys? So Kitty batch is the afternoon batch, guys. AWS Kitty. Yeah. Yeah, these are the commands, guys, to install the Kubernetes cluster, manual Kubernetes cluster. So I'm uploading it to your drive. What is that, guys? I make IT, right? I make IT batch 20. So I'm adding this file upload. You guys can download this one, Kubernetes installation commands. Yeah, guys, I uploaded. So Kubernetes installations commands. Yeah. So how you can install the Kubernetes or the Kubernetes installation command requirement. So one number of node, master node, T2 medium. So two number of nodes, worker nodes, T2 micro. Install Docker Kubernetes in both master node and worker node. Install kubeadm, kubectl in the master node. So commands, common commands for master node and worker node. Both these three nodes are there, right? Through three instances. You can run these commands in the three nodes. So all commands are executed at Ubuntu. Something like this is the Docker installation. This is the kubeadm kubelet installation. So then you can give the permissions. So then replace the API registry definition. Yeah, you guys use this one. Download public key, update kubectl, run this command. So these commands will be run on every instance, all the three instances. So then, so only master node you can execute these commands. So this is the installation step. I will show you tomorrow, guys, how you can do it. Okay, I will show you tomorrow how you can do it. The Kubernetes master and the Kubernetes master node and a worker node. Guys, understood? Guys, understood or not? So these are the commands, guys. And so slowly we will start to the container, pod, namespace, service, deployment, replication controller, replication set to daemon set, so persistent volume set, will set, so role, so secret config max, so Kubernetes core component, so namespace, what is namespace, namespace creation, pod using the custom namespace, creating a namespaces, so what is orchestration, so what is a pod, how to run our applications in Kubernetes, pod in two ways, meaning of the API kind metadata, Java Web Pod.maml, pod commands, pod lifecycle, what is a Kubernetes service, service connect set, control cluster IP commands, so node port to load balancer, manually created, the pod is not recommended. What is replication controller, manifest file, replication controller data, what is a replica set, so examples of equality and set based characters, replication controller versus replication set in Kubernetes, daemon set, what is daemon set, pod creation ways, deployment, all Kubernetes commands, strategy, recreate strategy, rolling update strategy, blue and green deployment model. What is blue and green deployment model? Advantage with the blue green model. So environment, users V1 and V2, V1 still running. Advantage with the blue green model. Practical, auto scaling, horizontal scaling versus vertical scaling, metric servers, EKS, EKS, EKS creation, EKS cluster creation. So ingress examples, Kubernetes core components, EKS, Kubernetes architecture. Guys, understood? So mostly we will complete it this week. Next week, Kubernetes. Kubernetes is the most important topic, guys. We need 1 week to understand this. Okay. Then we will start the Jenkins for integrating the CI/CD. Okay, guys. So that is the real-time project one. Then I will show you the other real-time project, guys. Okay. Guys,
Yes, sir.
understood? Who left, guys? Funny left. Okay. Okay, guys. So we'll continue from tomorrow.